In this course, we're going to look at what we actually want our gas flammable lens to do for our patient. There are certain aims that we have with the gas flammable lens fit. We want the back surface curvature, the back optic zone radius, to match as closely as possible to the corneal contours. We want the lens to cover a large proportion of the corneal diameter. We want the lens to be well centered and fairly stable, moving well on blink. We need to fully correct the patient's prescription to give them the best vision possible. And we want to fit the lens which is going to give the most healthiest fit possible. So let's think about how we do this. When we're looking at fitting a gas flammable lens, the first decision we need to make potentially is whether we're going to fit an aspheric or a spherical multi-curve design. Both lens types have their advantages and disadvantages. We also want to think about what type of material we're going to make the lenses out of. Now, each gas flammable lens material has individual features and benefits which we need to consider based on our examination of the patient. Now, there's a series of measurements that we need to take to enable the lenses to be manufactured accurately. So what measurements do we need and how do we take these? And then finally, when we've got the lenses in on the patient's eyes, how do we assess this lens fit in a reproducible and consistent manner? So let's look at two different types of lens design, a spherical multi-curve versus an aspheric. So let's think about the differences between the two designs, what are the advantages of each type of design, and why we would choose one type over another. So a spherical multi-curve. So what is a multi-curve design? A multi-curve design consists of a central radius, which is the back optic zone radius, over a back optic zone diameter. There are then three or more peripheral curves, which are blended to create a smooth contour or continuous curve. This produces a very good match for the corneal curvature and gives a lens that's really very comfortable. Now, with a spherical multi-curve, we have the option of being able to adjust these different curves independently of one another. And this is something that an aspheric lens cannot do. So this flexibility means that we can fit non-average cornea. Because the optics are based on a spherical optic zone, we get very good vision and there's no induced astigmatismal prism when the lenses are fitted. We can check the back optic zone radius with a radioscope. So for those practices that have one of these instruments, we're able to verify that the lenses are correct. The lenses, from our point of view, are very easy to manufacture. We can make them in a wide variety of designs, including back surface toric, front surface toric, and bitoric. Now, aspheric designed gas flammable lenses have become very popular over the last few years. And this is because the cornea is a prolate ellipse, so therefore it makes much more sense to fit an elliptical cornea with an aspheric elliptical lens. So a full aspheric design essentially has two main curves, the main aspheric curve to match the corneal contour and a secondary curve which contains the edge lift. Now, without this edge lift there would be no tear exchange and the lens would be very difficult to remove. So because we've fitted this aspheric cornea with an aspheric design, the comfort is very, very good. The lens fits very well. There's no defined back optic zone diameter, so therefore patients with larger pupils, particularly at night, won't suffer with the flare and glare that sometimes they can have with a spherical multi-curve. Because the lens follows the contour of the cornea better, you get better tear exchange due to capillary action. The aspheric lens tends to settle and center better on the cornea. And in the same way as it is with spectacle lenses, aspheric lenses are thinner. So this increases the transmissibility of the lens and also improves the comfort for the patient. The lenses are designed to clear the apex of the cornea, so it's very easy to see the fitting pattern with the introduction of fluorescein into the tear film. Finally, aspheric lenses tend to have a lower edge lift, which, while still enabling the patient to remove the lenses, also improves the comfort. And then finally, we have a combination of the two. We have a spherical back optic zone diameter combined with an aspheric periphery. So this gives us the benefit of spherical optics, but also the benefits of an aspheric periphery to fit the cornea better. So any patients that non-tolerate on aspheric optics due to their not liking their vision can be switched into an aspheric periphery design, and it will work very well. For most patients, average patients, aspheric lenses are a better choice. They fit better, they give better comfort, there's fewer long-term issues. The lower profile and thinner lenses reduces initial patient awareness and speeds up the adaptation time. So we recommend that you fit aspheric lenses as a first choice lens.